Hi, happy Tuesday. As you know, we're doing a lab today. I haven't put my coat on yet. I'm actually recording this on Monday before I head out. Just wanted to kind of get some quick stuff for you. Looking at our objective and taking a look at the lab. I'm going to have available to you, we're going to assign roles in just a minute. Available to your student driver will be some additional resources if you so choose to use them. Reminder, your student driver is also the person that can go ahead and raise their hand, ask questions of live me here in the classroom. Your lab's going to look like this. Everybody's going to actually be doing a paper lab. We are going to be using materials. Your gopher is in charge of materials. Your team captain is in charge of hopefully keeping everybody on track. And your timekeeper is the person that's going to be watching the clock, making sure that we are meeting our goals of actually staying on task. I did put times onto the board and the objectives into the agenda to try to help you stay on track, timekeepers. Hopefully we're able to use those. A couple key things that I want to point out to you right here. Front of the lab looks like this. It's the side with 2 boxes. Back of the lab is the side with all the big lines. So we're going to go ahead and try to do the front first and then go to the back. It doesn't really matter which order you do it in, but I want you to go ahead and follow along that way simply because then you get to the conclusion at the end. The conclusion asks you to go ahead and consider what happens to a refracted wave. It's the thing we're discussing today. And to be specific and use details from the lab in your answer. The other challenge I'm going to issue to you is to try to use our vocab. Trying to kind of resource, these are all things that we've at least discussed, if not drawn in class, using these examples for our vocab. So I turned it into just kind of a living vocab wall right here on the backboard to give you that resource to be sitting there and available to you. So that's what's going on with that. Let's take a look at our objective for today. It is the 5th. Oh, it's the 5th. Happy anniversary to my beautiful wife. I can understand how light reflects, how light refraction is affected by water to create optical illusions. So this is our intro part here. Hopefully I can keep it here in the 3 minutes. We're going to review and assign lab roles. Take about 3 minutes for that. I already discussed a couple of those already to kind of review what they are. You'll have about 34 minutes then to complete your lab. Timekeepers, that's one of the things you're going to be focusing on. Our debrief, we're going to do that for the Padlet. A Padlet's going to be set up. When we get to the debrief portion of the class, I'll pull it up on the main board, and so student drivers, you'll be able to go ahead and grab a computer, put your comments into that Padlet. And we'll take the last 4 minutes for some cleanup. Let's take a look at what vocab we have here on the board. No surprises, nothing we haven't talked about in class, just put some pictures with it. This reflection, this is the one we just talked about yesterday. Our source is the light right here, comes down, we got our barrier, and then of course this is the way that our goes at the same angle as it goes out. Absorption shows our light coming in and getting absorbed. This was talked about in one of the examples yesterday in class. They talked about how, say I've got a blue shirt on, the blue light is actually, all the other light except for blue is absorbed here, which brings me to more of the scattering. Blue is what comes back out off this shirt. That's what you're seeing with that. Try to get a little creative with this one down here, our sound wave. Compression, very close together. Rarefaction, kind of a mess, out of control, all over the place. Compression again. Rarefaction again. Come back to these guys in just a minute. Refraction, another one. Try to get a little creative with it. This wrote the word refraction as our pencil sitting in the water. You're going to be doing this part in the lab today, so that'll make a lot more sense in a minute. And then our echo, so our sound wave bouncing off of a barrier. Echo, echo. Coming from the source of the guy standing here. Now these two guys, you are familiar with them both. We did use these as examples in class. This guy, hopefully you recognize. He knows it's not easy being green. Hi-ho, very low-pitched, so I have a low frequency. So we see here with Kermit the Frog that he's more low-pitched, and so the wave frequency is also low. Our high-pitch example, in some classes I said Miss Piggy, but I also pointed out that Miss Piggy and Yoda are the same actor. So here we have Yoda, high pitch, do or do not, there is no try. High frequency, so his wavelength for what this sentence sounds like is a lot closer together. So that kind of gets us touched on to what we're doing today. This stuff is going to be up here on the board available to you. As you know, I erased where homework was now. As you know, Friday is when we're planning on doing our test on this stuff. So we want to stay focused today. Getting through this lab, moving to some lab activities tomorrow. I know I went a little bit beyond my time, but I also discussed some of the roles. So even though it says 3 minutes and I went long, I'm going to go ahead and own that since I already took some time here on reviewing lab roles. We'll go ahead and get them assigned, and you guys can go ahead and get started. Thanks so much, and happy Tuesday.